Now we will have the keynote session, the 5G route to national success and the thumbs up policy framework. Please allow me to invite on stage Madam Aruna Sundarajan, Mr. Rajan Matthews, Mr. Jitendra Singh from Qualcomm, and Mr. Pradeep Gupta. Over to you.
The session that we had just now, thank you very much, Shukanto, for setting up a context to what we are going to discuss today, because I think you covered the evolution, the technologies, the usage, and so on. So I think it gives a very good overall picture. I would first request Mr. Jitendra Singh from Qualcomm to please share with us his views.
Good morning to all of you. Thank you. So I will be talking about how 5G, what is evolution. We have already seen that in the previous presentation, and how we can actually achieve some national success on this. So I will start with the work which is happening in India, in the government, the work which was done in last 5 years, where we had some excellent visionaries who came together to form a 5G high-level forum to create vision for India and work parallelly with what was being done globally, especially in ITU, and the way we adopted and the way we worked in ITU. So all those works which happened in over last 4 years actually, and which is getting concluded this year in World Radio Conference starting next month. So I will be touching some details about there. So there was a National Digital Communication Policy which was created, and this was work which was one of the extensive consultations which happened, and most of us were participants of those consultations at various under various forums, and we actually saw a document which came out, which is not only a plain paperwork document, it is actually something which is implementable, especially when we see 5G as a technology which is the baseline for this kind of progress which we want to see at the national level. So strategic objectives which were defined in this NDCP was provisioning of broadband for all, creating 4 million additional jobs, enhancing contribution of digital communication sector to 8% of India's GDP, propelling India to top 50 nations in ICT Development Index, which was 134 in 2017. Enhance overall global value chain on India's contribution in global value chain, and ensure digital sovereignty. And there were 3 missions which were defined: Connect India, Propel India, and Secure India. So I will only focus on Connect India, because this is where 5G technology right now gets a direct impact. So we had the outcome of this document was that we will have a universal broadband coverage of 50 Mbps to every citizen. If you start calculating it backwards, how much of bandwidth will be required, how much of bandwidth will be required for the backhauls, for the core network, all those things, and the kind of processing capacity which will be required. So all those things have to be based on this kind of use case where every citizen has got 50 Mbps. 1 Gbps connectivity to all Gram Panchayats by 2020, which will be 10 Gbps by 2022. So I know BharatNet is already working on rolling out fiber to all Gram Panchayats. This is a work which is in progress. And actively, the way things are happening is very exciting, and they are very supportive of 5G deployment very soon in India. Enable fixed line broadband access to 50% household, and some other parameters of Wi-Fi, and having number of hotspots of Wi-Fi. So these are some key items of Connect India, Mission Connect India. So One thing which happened yesterday was there was a CEO's roundtable conference in MIT, and it was chaired by Honorable Minister of IT and Telecom, Shri Ravi Shankar Prasad. And it was a whole day event where more than 50 CEOs of different electronic companies were present. And each one of them was given an opportunity to give the issues with respect to development of with respect to local manufacturing of electronics in India. And the entire day, ministers were there. And at the end of the event, minister said that his focus is to make India a hub of 5G. So that actually shows the way government is actually thinking, the way government is actually planning for growth. So how it can actually happen, we can have design houses which are basically software oriented activities where more of R&D work can happen. So more R&D oriented activities. Another is actually doing local manufacturing. And this is an important factor if we see the geopolitical situation right now which we have. So developing or having local manufacturing of components, PCBs and different accessories. So these were the two focus items of yesterday's outcome of the entire day's workshop or the work which happened yesterday in the MIT. So I just wanted to share this with you because this actually shows that where we are going as country for 5G. If the government is focused on making India as a 5G hub, then it means that all of us are actually on the right track, because that is the theme of this event also. So I will I tried to pick up some facts and figures, and because these are voice and data, so voice is here and data, I'm showing you some data in terms of numbers. So if you see these numbers and then we see how India can fit into it, or what are the places where India has to move up to reach the levels. Sorry. So GSMA intelligence report which came in April 19 actually says, this is about connections and networks, these data sheet. It says total cellular connections will be about 7.8 billion by, currently this is the number, 7.8 billion. 5.1 billion unique subscribers are there by Q1 19. This is expected to grow to 8.7 billion numbers by 2023. Having 5.6 billion unique subscribers. And we are not talking of IoT in this. There are 227 operators in 90 countries who have invested in 5G right now. And 15 operators have already announced the limited 5G service launch. 27 have turned on 5G base stations, but their commercial networks are still to be launched on that. There are 185 countries in 185 operators in 83 countries which are actually have either demonstrated or testing or carrying out trials of 5G in different frequency bands. So India is still to get into this category, and in fact there are only two groups which are left to get into this category. One is African countries, another is India. So I hope that now with IMC and then this coming in next month, we will start this work with demonstrations of 5G, and maybe subsequent to that we will actually get into long-term trials. Policies have been set by the ministry, by the Department of Telecom on issuing of trial license for about a year, and the processes which have been made much smoother. And I would like to thank Aruna Madam for that, because the work which was a kind of decades old processes which were there, which were very slow processes, which were taking time in the department, those have been resolved. And now the process which has been now created is that the license will be given for a year, and if you do not, once you apply and if you do not get any response within certain number of days, I think 4 weeks, then it is deemed to be assigned, and all those things are being made. So life has become very easy for operators or for the people who actually want to carry out trials. Spectrum will be given, and the cost or the amount of the charges are very less. So it is a very good approach which government has taken, which will help India to actually be into this category. So 91 operators in 52 countries have announced their intention to make 5G available between last 2018 to 2022. This is the 4-year cycle where people are actually implementing. Someone can actually ask that why it is not that we or any other country has already launched 5G. So 5G is a commercial word, but in terms of ITU, it is known as IMT 2020. And IMT 2020 means it will be finalized and frozen in 2020, that is December next year. So that is the time frame when the technology will be frozen by ITU. And 3GPP is a commercial organization from where we pick up these terms called 5G, 4G, 3G and other terms. So official implementation, that is the reason that most of the countries are focusing on 2020, because after that, once it is frozen, they can actually then have official 5G or IMT 2020 technologies deployed. Coming to traffic flow data, in China, as of August 18, 788 million were accessing internet via mobile, which accounts for 98% of Chinese netizen population. China user spends on average 200 billion hours on apps, 4.5 times longer than what we do in India, and most of us are actually using mobile phones in India for apps, using various apps. Similarly, Cisco had a number of studies, and important thing is that global cloud data center traffic is expected to reach 19.5 zettabytes per year by 2021. Zettabyte is 10 raised to power 21 bits. So similarly, this said that global cloud data center traffic will represent 95% of total data center traffic by 2021 versus 88% of 2016. 2021, video will account 85% of traffic. So this is what we have been always saying as industry, that video will be the key or the killer app in whether it was 4G or 5G. This is the killer app in terms of consuming bandwidth. And by 2021, data stored in devices will reach to 5.9 zettabyte, which is 4.5 times higher than what is stored in data centers. And in 2021, largely due to IoT, the total amount of data created will reach 847 zettabyte per year from 218, more than or 4 times, nearly 4 times of what was there in 2016. Similarly, on artificial intelligence, 2022, AI augmentation will create about 3.9 trillion of business value. 2025, AI edge devices will rate about 100%, and it means AI will be nearly in all the devices by 2025, and they will have AI processors in all devices. So, and China's economy benefits from most from AI, and their GDP becoming 26.1% higher in 2030, which is additional 7 trillion USD. If you see North America, GDP grows by 14.5%, that is 3.7 trillion. Northern Europe, 1.8 trillion, developed Asia by 0.9 trillion, and Latin America by 0.5 trillion. So this is the impact of artificial intelligence which is based on 5G. Coming to 5G economy, overall impact of 5G will actually come by 2035, because by that time only most of the population on the globe will be using 5G technology, or industrial usage will be there, which will be implemented by that time. So it is expected that that is the time when maximum benefit or the full benefit, economic benefit could be realized. And this will cover various ranges of industries, retail to education, transportation to entertainment, and anything and everywhere, whether it is strategic use, whether it is standard commercial use, whether in defense, space, anywhere, it will be used everywhere. So production of 12 trillion worth of goods and services are enabled by 5G, and 5G value chain alone could generate up to 3.5 trillion of revenue by 2035. So by 2035, 5G will enable about more than 2.4 trillion in economy output across the automotive sector and its supply chain. So that is another estimate. So these are from various organizations which I have source I have mentioned here. This is from Ericsson Mobility Report, which came last year, which actually shows that there are a number of, so if you see here, there are different colors which actually depict different technologies, and they keep dying down. And in 2019, we are expecting to have 5G to come up, and it is expected by 2023 there will be 1 billion subscribers using 5G. And this is no IoT, this is no fixed wireless access. It is devices, it is standard communication systems. So how 5G is actually addressing, again, this is from Ericsson Mobility Report, how addressing, what are the opportunities addressing different verticals with 5G. So it is expected that by 2026, we will have $1 billion extra, which is shown here, revenue which will get generated from 5G, only purely from 5G. And how it is distributed is this $1 billion is there are various services which I have mentioned here. Unfortunately, we cannot see here on the screen. So we have 9% from agriculture, energy and utilities. So there are different categories and different services which I mentioned, and that show that what is the kind of growth which will, or what kind of economic benefit which is coming from there, what is the revenue generation which is happening from those different sectors. So it means that it is not only meant for standard communication, there are different sectors, different use cases, which was also projected by the previous speaker on how 5G is actually going to get deployed. It is not only purely for your devices or your phones. It is going to be into IoT, into machine type communication, into enhanced mobile broadband, into ultra low latency systems like medical requirements. So it will automotives, everywhere it will be there. So all those will actually implement, will ensure that this kind of growth actually happens. All this requires a spectrum. That is what 5G is all about. We will require different kind of peak data rates, different kind of latencies, mobility will be of different nature. One example of mobility I would like to give that it is important for us to understand this important factor, mobility, because we say mobile phones, but what is mobility in terms of 5G, how is it different? For example, in ITU, China said that they want mobility of 500 km per hour, where their trains will be moving in rural areas with this speed, and they want a particular kind of quality of service which they should achieve while they are moving with this kind of speeds in using 5G. India said, no, we are not having this kind of requirement. In our rural areas, we will have very low mobility. Because we have low mobility and our areas, our villages are in generally remote areas, and they are spread over large, different areas, large areas, different difficult terrain areas. So we require a different category altogether, that is low mobility and large cell, so which is known as LMLC, and India pushed for this, and it has now become part of essential requirement for 5G in ITU. So standards are being formed around that. So that means there's a different use case of mobility for India as compared to China or maybe some other countries. So different countries have different understanding of various factors which I'm showing here, and we should be actually focused on what is our requirement and where we have a common view, and where can we go global and where can we be a local player. Spectrum efficiency is another part. Energy efficiency, for example, you want to put a device in a, say, in a field where a farmer wants to know what is the level of moisture in the soil. If you put a device there which will give reading after, say, reading after every 1 month or maybe after 2 months, that will actually, you cannot go and charge that device every 10 days or every 15 days. You would like that battery life should be as long as 15 years, so that you don't go every day there and keep charging it. So those are the kind of energy efficient devices which we are talking of, which means very small, very cost effective solutions which are required for this kind of battery requirements. Then there will be different kind of user densities we are talking of, network capacity, reliability, and user types. So different requirements are there. I just put some things. So there's MMT, massive machine type communication, the critical machine type communication, enhanced mobile broadband, fixed wireless access. So it means same system you can use for mobile as well as for doing point-to-point communication also, or point-to-multipoint communication also. So there are various use cases which were not there in the standard communication systems. For this, it all requires a different kind of spectrum categories. You require spectrum for doing enhanced mobile broadband in millimeter waves, which was actually presented in the previous presentation. Great details were shown, and that was an excellent presentation. Similarly, you require mid-band, where you require for mobile broadband, URLC and MTC. And I think India is auctioning 3.5 gigahertz spectrum band. Right now, they are planning to auction this band. So this is somewhere we will have a play immediately. And then we require low band also, which is around 2 gigahertz, 600 megahertz and 700 megahertz band, the new bands which are there. And we require both licensed and unlicensed spectrum bands, because that is how it will actually work. So this triangle is a famous triangle of IMT 2020 or 5G. It actually talks of 3 points. One is enhanced mobile broadband, massive machine type communication, which is IoT, also known as IoT, and ultra reliable low latency communications. So all spectrum requirements, all communication requirements, technology development is based on these 3 parameters. So various cases or examples are given here. But for this, you require both licensed spectrum, unlicensed spectrum, a combination of that. You also can go for licensed shared access, where a user like Defense or Department of Space is using certain spectrum. In certain areas, they are not using that spectrum that can be made available, because most of these will be millimeter wave bands. The wave will not travel more than, say, maybe 1,000 meters, maybe 1,200 meters at the most. So you can actually use those spectrum bands effectively while sharing and ensuring that the protection is ensured for the incumbent. Then you can do spectrum sharing also. This is an example which I have taken from Italy, where auction was done, and it was in the auction document, it was very clearly given that suppose a company A or the operator A gets spectrum in Delhi, operator B gets in, because spectrum is limited, operator B gets spectrum in, say, Rajasthan. So operator A can use, suppose operator B is not using that spectrum for whatever reason, but they have bought that spectrum. So operator A can work with operator B and they can use that spectrum effectively till the time operator B decides to start using some portion of that, and then they can close. So this is a sharing model which was based on which auction was done. So this also ensured that the overall pricing of spectrum or the final cost of spectrum came down. Then there was access obligation. How and where, because this is, like it was said, that millimeter waves will not travel very far. So number of small cells will be much larger. So whether you will be, what kind of access obligation is required. So that is something which is a policy issue which has to be seen. A spectrum is required for indoor usage, which I have said this because in many cases, satellites are using same spectrum. So when satellites are using same spectrum, if you are using same spectrum for indoor usages, you are not causing an interference to satellite systems. So that same spectrum can effectively be used without wasting that spectrum. So this is what I've actually meant here with this particular point, that we can actually use that same spectrum for indoors activities, for automotive work, or for automation of industries, for robotics kind of usages. Then spectrum is required for MTC and IoT. This is into this particular category. But what I also want to say here is, when we are talking of MTC and IoT, we have seen the security issues because IoT can cause severe havoc. We recently saw some drones doing some kind of activity in UAE and Saudi Arabia, and 2 refineries were actually blasted off. So these kind of IoT activities can cause security issues, not only because if you are using IoT, because like I said, IoT is going to get into every corner of every requirement, every usage, whether it is your home or whether it is your defense requirements or it is in satellite requirements. If someone can control IoT from remote areas, it can actually cause havoc. So security is an important part of that, and some policy should be around that. So like I said, that what all we require different kind of spectrum bands, which I actually showed in the previous slide. So we should ensure that a spectrum is available, a regulator ensures that spectrum is available. quality of spectrum is good. We can say that 100 megahertz is available, but if it is available in 10 megahertz chunks spread all over the place, it is of no use. And the pricing of the spectrum should be reasonable. I will use word reasonable, so that it is used. It is not left unused. No one buys that spectrum if it is very costly. And we saw some article today in the media also, of course not sponsored by me, but that actually says that the way spectrum which was not sold has caused so much of loss to the exchequer. So with this, I conclude my talk. We have excellent national digital communication policy. We also see that there are remarkable social and economic impact of 5G at national level. There are different countries who have taken leadership. We can also be part of it. We are still about to be there. So it is only one more step to ensure that we are there by ensuring right spectrum policy. So we should have a real clear spectrum roadmap for ensuring 5G in India. Thank you.
Thank you very much, Jitendra. Very impressed with the wide range of data that you had in that, to show what are the different kind of things that are going to be required as far as rolling out 5G is concerned. Thank you very much.